Multiplying and dividing rational expressions. This is section 6.2. Okay, so we learned before what a rational expression was. It was a ratio of polynomials, but that bottom could not be zero. Like fractions, rational expressions can be multiplied and divided. The product is what we call it when we multiply, and the quotient is what we call it when we divide. And we always express these things in their simplest form. So instead of saying 3,000 over 6,000, we always would rather say that that's 1/2. We always like to say simple. To multiply, we factor both the bottom and the top. Then we determine any non-permissible, and then we multiply the numerators together and the denominators together and simplify. If factors are common to the top and the bottom, we can cross them off. So you can see here we have x plus 4, x minus 1 over 3x, x plus 4. There is a common factor that could be crossed off. What's not allowed is if you have 3x minus 1 over 3x, because there's a similar term, you don't get to cross those out. Okay, that's like saying 2 plus 3 over 2 is the same as 3. So what you're telling me is 5/2 is equal to 3. Well, this is $1.50, that's $3. I'd much rather have $3, okay? So you can't cancel in that way, only if it's common factors. How to divide rational expressions, dividing fractions. To divide one rational expression by another, multiply the first by the reciprocal of the second, then proceed the same as multiplication. So I call this kiss and flip, because you kiss and then you flip the second one. Okay. What comes in tricky with rational expressions with polynomials is these non-permissible values. So there's two kinds of division. Expression b and d are in the denominator in the beginning. So we have b and d in the denominator. But then when we flip CD, c becomes a denominator as well. So we actually get more non-permissible values that we have to check out for. So in this case, b could not be 0, d could not be 0, and c could not be 0. Okay, let's see how this looks. Determine each product. Identify any non-permissible values of the variable. Okay, so remember when we were multiplying, it said first to factor. So the top doesn't need to be factored, but the denominators sure do. So this first one, we need to factor this. It needs to multiply to be 6, add to be -5. Well, I think that's going to be x minus 3, x minus 2. And in this case, it needs to multiply to be 4 and add to be 5. So I think I'm going to go x plus 1, x plus 4. Okay? Before I do any canceling out, I have to do my non-permissible values. So I say x minus 3 cannot be 0. X cannot be 3. And you're going to get good at these so you don't actually have to switch the sides over. So in this case, x could not be 2. In this case, x could not be -1 because we'd get 0. And finally, x could not be -4. So there's my non-permissible values. Okay, now that I've done non-permissible values, I can multiply. So I multiply them all together, and then I look at the common factors. Well, there's a common factor, and here's a common factor. So what I'm left with is 1 over x minus 3, x plus 4. Okay, that has been simplified. And afterwards, you would write those non-permissible values behind it. Next one, state all the non-permissible values of the variables. So we're looking at the denominators. Here's a denominator. So c could not be 0 and d could not be 0. Here's another one. G could not be 0 and h minus 6 couldn't be 0. So h could not be 6. But this is a division question, so I'm going to end up kissing and flipping. I'm going to end up multiplying by g h minus 6 over e minus 2 f plus 1. So this now gives us a whole new set of non-permissible values. E could not be 2 and f could not be -1. So division does lead to a bunch of new non-permissible values. Okay, determine each quotient. Identify any non-permissible values in the variable. Okay, let's just start simple. 3/4 divided by 9/2. So we go 3/4, we kiss, and we flip. Okay, so we could get 6/36, or we could cancel right here. We could say 3/9 is the same as 1/3, and we could say 2/4 is 1/2. So it's like we have a 1 times 1 over 2 times 3, so that's 1/6. Okay, there's no non-permissible values here because those are all real numbers. Let's look at this next one. X plus 3, x minus 3. So I'm going to still just leave it as divide, and I'm going to factor. So I'm going to get 4x minus 3. Now before I go kissing and flipping, I have to do my non-permissible values. So in this case, x cannot be 3. Here again, x cannot be 3. But when we kiss and flip, we're going to get this in the denominator. So x can also not equal 0. So let's go ahead and kiss and flip. So we get x plus 3, x minus 3, kiss, flip. And now we can cross out common factors. We're left with 4x plus 3 all over x. What we can't do is we can't go crossing off x because that's not a common factor. Okay? Let's try the last question because we have time. We have x minus 7, x plus 4 divided by that big thing. So let's look at factoring first of all. So we have x minus 7, x plus 4. This one we have to factor. Two things that multiply to be 15, negative 15, add to be negative 2. X minus 5, x plus 3. I think that'll do it. And on this one we have x plus 4x minus 5. Okay, so before we go kissing and flipping, we have to say our non-permissible values. Well, x could not equal negative 4. There's another negative 4. X could not equal 5. And then when we flip, we're going to have these two as well. Well, this is just x could not equal 5, and that's x could not equal negative 3. Okay, now we can kiss and flip. X minus 7, x plus 4, times, flipping this, x plus 4, x minus 5. So I've put this on top, and I'm going to put this on the bottom. X minus 5, x plus 3. And now I'm going to cancel out common factors. X minus 5, x plus 4. So simplified, this is just simplified to x minus 7 over x plus 3, which I think you will agree is a whole lot simpler than that. But don't forget, there's these non-permissible values. It simplifies to that, but these things are not allowed. X cannot be those things.